science class today, Chapter 2, Section 2, SI units. We're going to take this lesson and split it into two separate lessons. And in the first section, we're going to talk about the International System of Units, or SI units. This system of measurement is used all around the world, and it can also be titled the metric system, in which it uses a power of 10 to separate different levels of measurement. We're going to learn about first the sequence of base units that are used to measure different types of things like length, like time, like temperature, volume, mass. And then we're going to learn about the prefixes that they put on the front of those base units to designate the different types of size for those types of measurement. To do that, we first need to have a good understanding of those units, the prefixes, and then to understand how they work together, you actually have to learn how they can be converted amongst one another, so you can change from one unit to another based on the designation or the size of that measurement. We're going to do that with what's called the stair-step method. So you're going to see Mr. Shane jumping on some stairs in just a minute here. The system of units, or the SI system of measurement, was first designed in order to create what would be a worldwide standard. This idea of everybody measuring things the exact same way, so there aren't ways in which people can get things confused. Can you imagine if you measured something one way and I measured it with something else, and we tried to come to an agreement on what that value was or what that measurement was? It'd be complete chaos and confusion. So we need to work together to create this one semblance system of worldwide standards that everybody uses. That way scientists that are working on different parts of the planet can have the same way in which they're keeping track of data. Now, the SI system, the International System of Units, or metric system as it's sometimes called, is a system of base units that have a specific measurement that they're going to be taken care of, such as meters is taking care of the length measurement, liters takes care of what would be volume measurement, grams takes care of what would be mass measurement. Those are commonly the three most used. There are a number of others, and those can be found on the bottom of page 50. Length is meters, mass is kilograms or grams, temperature is in Kelvin, time is in seconds, electric current is in amperes, the amount of a substance is measured in moles, and the intensity of light is measured in a candela. And you can see at the bottom of the page the symbols that go along with those. Those are what we call our base units. That's basically the different ways you can measure something and how they're going to go about communicating that within that unit. Now, how about things that get really big or really small? The base units become different by adding a type of prefix or a part of the word to the beginning of that word, so you can tell how big or small that measurement is by using the same set of units. Now, this is set up in what is called a multiple of 10 or powers of 10. That way you can show from one unit to the next. It's 10 times larger, 10 times larger, 10 times larger, or the opposite. It's 1/10 or 10 times smaller.
A millimeter, you can understand, is about as long as a grain of sand. When you buy food at lunchtime, it's about the thickness of a dime.
A staple from side to side is about a centimeter wide. A fingernail on a girl or
to yourself, Mr. Shane, I already know how to measure certain types of things. I know how to measure length and time and volume and mass and temperature because we use those types of things all the time. That's our customary system of measurement, and it's listed right here. We measure length in feet, in yards, in miles, those types of measurements. If something, talking about the amount of a liquid or the volume of something, we're going to measure that in ounces. If it's something's weight, we measure in pounds. In temperature, we're talking in Fahrenheit. All those things we're really used to using here in the United States. See why I labeled that US? Because that's our standard of measurement, our custom way of measuring things, but it's not necessarily what's accepted in the scientific community. They're going to use this worldwide standard and what are these base units for best practices. We're going to focus in on learning those best practices, learning how to convert between those different types of base units, and how to use those prefixes just like we can use those customary measurements, because we're going to get really, really used to those and really, really good at those. Come on. If you have your textbook in front of you, it's going to be helpful to reference what's on page 50. Table 1 are base units, and then Table 2, those SI prefixes. We kind of already looked at what those base units are for the different types of measurement. Now we're going to jump to what those prefixes are. You see that there's a word written down. That's the part that goes in front of what would be one of our base units. Here's an example of meters, grams, and liters as what those base units usually are. And then the prefix actually stands for what the multiplier is, or the power of 10 that name represents for those types of measurement. If we go up our stair-step method, our conversion rate here, you're going to see, and on the table you're going to see that it increases by power of 10. If you go down, it decreases by that same power of 10. So if we start here at meters, liters, and grams, and we go up, a deca, meter, liter, or gram, stands for 10 times larger. Hecto stands for 100 times larger, and kilo stands for 1,000 times larger. Let's go back to our middle section here, meters, liters, and grams. 1/10 or 10 times smaller than 1 unit would actually be deci. You know the decimal system as having those decimal places. That's where that name comes from. Below that, a deci, meter, gram, or liter. 10 times smaller is a centi. You might be familiar with centimeters that are on your ruler. There are 100 centimeters in 1 meter. Your ruler of 12 inches that you're customly used to using, because our customary method has about 12 inches and 30 centimeters. And 1/10 smaller than 1/100th or centi is actually going to be 1,000th. Now you'd think, well, milli sounds like million, so that should stand for that. Don't get it confused. Milli is our reference for 1/1000th of a standard measurement. Now in Table 2, it gives you two other ends of the spectrum. It tells you what value of micro and nano is on the smaller end, and then the values of mega and giga. You may have heard megabytes and gigabytes in terms of the data and the storage that your computer or your phone can handle. Those are massive, massive numbers or multipliers with this prefix system. Now we're going to use this conversion system and go jump on some stairs to practice what would be on the rest of this piece of paper. You should have this out ready to go, and you can follow along with the example below. And then to complete the assignment, you're going to need to maybe use stairs yourself or just draw right on this piece of paper. You're jumping from step to step to step to help you remember this. I also have a cool acronym listed right on here to help you remember kilo, hecto, deca, the base unit usually, and deci, centi, and milli. You say King Henry doesn't usually drink chocolate milk. King Henry doesn't usually drink chocolate milk. And you can remember kilo, hecto, deca, unit, deci, centi, milli. All right, 8th grade, let's put this stair-step method to use to learn how to convert between what would be these SI units and their prefixes. I've got this sheet in front of me that has an example, and I've got the live set of stairs. You feel free to use the set of stairs at your own home. If you don't have one of those or you don't really want to, there's, guess what, a set of stairs on here, and what you can draw from one spot to the next while we're making those conversions. We'll go through the example problems together down here, live with Mr. Shane doing some dancing on the stairs, and then your assignment on the back is to continue to do that by finding that value on the stair and then where it's actually going to jump to. There's a couple rules for how to do this stair-step method. It says when moving up the stairs, count how many stairs you are moving and divide by the many powers of 10, or move your decimal point that many places to the left. When moving down the stairs, count how many stairs you are moving and multiply by that many powers of 10 and move your decimal point that many places to the right. Now let's put that to use. Here we have listed our kilo prefix, the hecto prefix, the deca prefix, the base units, our deci, centi, and milli units. we're going to find that unit and start at that specific prefix and then move from that location following those rules. It says when we're moving up the stairs, you move it to the left. Our decimal point moves to the left the number of times you went. When you're moving down the stairs, our decimal point moves to the right. Let's give it a try. First example problem says, what is 10 centimeters equal to in decameters? Well, first thing I need to do is start at the centi prefix. So I'll go to my stairs. With your pencil, you can put yourself right on that centi location. So I would start 10 centimeters is right here at centimeters, and I would move myself to decameters. I'm going to go 1, 2, 3 steps. I went 3 steps up, so my decimal has to move 3 steps to the left. Let's try that out. If I started at centi and I went to decameters, centi's up 1 to deci, to the base units into decameters. I went up, my decimal point should move to the left. Therefore, right here on our example page, it says that that's moving to the left 1, 2, 3. When we started at centimeters, centimeters are actually smaller than decameters. Therefore, the ending result is going to be a smaller value. That makes a lot of sense, right? If it's a smaller value, it's going to be fractional size of what 1 decameter actually means, which is 10 full meters. That's a pretty long distance. If you look at the second example, it says I'm moving 3 powers of 10 down the stairs, so I know that I will multiply by 3 powers of 10. What if I'm going from 10 decameters to centimeters? It's the opposite problem. Let's give that a try. I'm up here at the decameters location. I go down 1, 2, 3 sets of stairs. Now I'm at the centimeters location. And if I went down the stairs, I'm moving to the right. And the answer here, if I'm at 0.01, 1, 2, 3, moves over 1, 2, 3 to be 10 centimeters. So 10 centimeters is worth not 1/10, 1/100th of a decameter, and 10 centimeters is that smaller value for the overall distance of decameters. Now on the back side, here are a number of different problems for you to try. We should probably do a couple of these together. With your metric system conversion sheet in front of you, our stair-step method that reminds us that kilo, hecto, deca, unit, deci, centi, milli stands for King Henry doesn't usually drink chocolate milk. We're going to use this stair-step method to convert these measurements into these measurements with our SI system. If there's some noise in the background, that's just the church tuning up music for what would be our worship this coming weekend. It says write the equivalent measurement. So we've got 5 dm. We just practiced with our units on the other side, and it was DAM per decameter. So dm is going to represent decimeters. I'm at 5 decimeters, and I need to change that to meters. If I'm at deci, I'm down here. It's a smaller value, and I'm going to go up to meters. So I went up 1. If I go up 1, I'm supposed to move that to the left 1. So my decimal starts here and move it to the left. I would actually write 0.5 meters right in this location. Letter B. 4 milliliters. I'm going to start at this location, and I'm going to figure out where that is. Again, my decimal point is always right here behind this, unless it's listed like in this example or in this example. It's usually right here behind that whole number value. I'm at milliliters, so I find milli on my set of stairs, and I'm going to start right here. Here's milli, and I need to move to liters. Here's liters. Now let's get there. I'm going up 1, 2, 3 steps. If I go up 3 steps, I'm moving my decimal 3 times to the left or to the right. Up is to the left, down is to the right. So start here, go 1, 2, 3. I put 2 zeros in front, and my final answer would be 0.004 liters. Letter C, 8 grams. Hopefully you're getting the hang of this. I start at what it gives me as this label, grams, and I move to what it's asking me to go to. mg is going to stand for milligrams. So we're at 8 grams. We're going to jump down 1 step, 2 step, 3 step. 8 grams is equal to how many milligrams? Well, if milli stands for 1,000, there are 1, 2, 3 steps. That means I'm going to add 3 zeros, 1, 2, 3. There should be 8,000 milligrams in 8 total grams. Now there's a way in which we can continue to do this, so it's going to get faster and faster the more we practice. 9 milligrams we would start at milli and we'd move to grams, just the opposite, up 1, 2, 3. 9 milligrams is a really small amount compared to how big an actual gram is, so that's only going to be 9 1,000ths, or in this space right here, 0.009. A couple other ones to reference. When it says cm, that's talking in terms of centi. M is talking in terms of milli. D is talking in terms of deci. If it says DAM like it did on the beginning page, it would be deca. If it says H, that's going to be our reference to hecta. So here's a hecka conversion. And if it says K, that's going to be our kilo conversion. So these little values here are just ways in which those prefixes are written as abbreviations. Now the rest of those, I'd like you to give your best overall effort and best try. If you need help, be sure to reach out to me. Tune back in tomorrow for what would be part 2 of section 2 in our SI units, where we talk about the actual types of measurements and the different ways in which we go about doing that. God's blessings. Good luck.